Hello, this is Mr. Wynn. Today's video will be about multiplying and dividing rational expressions. So a rational expression is basically a fraction. The good news is y'all already know basically what to do with fractions, how to add them, subtract them, multiply, and divide them. This one will focus on multiplying and dividing. Remember to simplify. You're going to divide the numerator and denominator by the greatest common factor, or GCF. So that's not changing. But the bad news is there's going to be variables involved now. For example, the letter x. Once x is in a fraction, the calculator can no longer do it for you. So you're going to have to learn how to do it by hand. And again, it's not that hard. It just involves a lot of factoring. So I'm going to review some with easy numbers and then do the problems. So when you simplify or reduce a fraction, you divide the top and bottom by the GCF. For example, in the old way, y'all knew to divide the top by 10 and the bottom by 10. So that would give us 1 over 2. Now that way doesn't quite work as well. It's not as obvious when we're doing the variables. So let me show you the new way. So we're going to factor first. So 10, let me do it like this. So I'll say that was the old way. The new way involves factoring. Factoring means breaking down. So here's the new way. Well, let's break down 10. If y'all can't factor it, you can just do this tree branch. It's 2 times 5. Those are the primes. That's it. So the top would be 2 times 5. On the bottom, let's factor 20. Well, I'm going to the side over here. 20 is 2 times 10. But 10 is not prime. So it's 2 times 5. Right, those are the prime numbers. So it's 2 2's and a 5. 2 times 2 times 5. Right, now I can cancel out. For example, I see those a 2 on top, a 2 on bottom goes away. All that's left over is on top is a 5. Ooh, that cancels out as well. 5 cancels out as 5. If there's nothing left on top, there's an invisible 1, because that's really 1 times 2 times 5. Whatever's left is our answer. So there's a 1 on top and a 2 on bottom. All right, if you do it this way, you will never ever have to reduce. So factor first, then cross out last. Now, involve variables, the steps are basically the same, but there's one extra thing. So here are the steps. First, we'll actually fix division to multiplication if you needed. We never divide fractions, and I'll show you how to do that on a later example. The step 1 is factor everything. We have 3 methods. GCF always comes first, then the ACX method, or difference of squares. So let me do a quick review on that real fast. So for the bottom of GCF, that means what's the greatest common factor? What can I take out of all the terms? And sometimes there's a letter, sometimes there's a number, sometimes there's both. So I have 4x cubed minus 10x squared. Well, 4 and 10 are even, so I can take out a 2. Now also the letter x is in both of them, the variable. X appears 3 times on the left, twice on the right, so I take out x with the lowest exponent shown, squared. And what's left inside would be, well, it's kind of like division. We're basically undistributing. 4x cubed divided by 2x squared is 2x. And negative 10x squared divided by 2x squared is negative 5. That's it. I factored out a 2x squared. If I distributed, I get the original problem back. So that's GCF. All right, the ACX method is you make an x. You put a times c on top. So a times c is the same as the quadratic form as a and c. So a is positive 2, c is positive 6. I multiply 2 and 6, that gives me positive 12. And the sign's important. You put b on bottom. Well, b is positive 7. So that's how you set up the x. Now our job is to find the 2 numbers on the side, the left side and right side. The 2 numbers have to multiply to the top. So multiply to 12 and add or subtract to the bottom, 7. So we're going to figure out what times what is 12. Well, we have 1 times 12, but that cannot make 7. That can only make 11 or 13, positive or negative. We have 2 and 6, but that still can't make 7. We have 3 and 4. Now 3 and 4 can make 7. We have to figure out the signs to make them add up to 7. Well, the sign on the bottom always will be the sign for the bigger number. So 4 is bigger than 3, so this is automatically positive. So what do I do to positive 4 to get positive 7? We'll have to add 3 to it. So they're both positive. We found the 2 numbers on the side. Put them in parentheses next to x. That's really x plus 3. Parentheses x plus 4. And the last step of the AC method is always divide by a. So a was 2. All right, you must reduce if possible. If you cannot reduce, get rid of the fraction by moving that denominator to the front. So this goes to the front. This is really 2x plus 3. On the right side, 4 divided by 2 reduces to 2. Right, that's the answer there. Right, if you FOIL that, if you distribute that, then you would get the original problem back. The last one is difference of squares. Well, technically, that's the same as the ACX method, but it's a shortcut. If b is 0, you're allowed to square root both things. Ignore that negative sign, the minus sign, and put them in 2 parentheses. So square root of x squared is x and x. Square root of 49 is 7, 7. Have different signs, positive and negative. If you FOIL that or distribute that, you would get x squared minus 49 back. You have to subtract 2 perfect squares. All right, so let's do the steps. So first is factor everything. For the top, we have 5 times x. All right, that's straight linear, leave it alone. Next is x squared plus 4x plus 3. So that's a quadratic. Or we're trying to avoid a quadratic format. We're going to do factoring the x method. So a times c is positive 3 on top. B is positive 4 on bottom. I'm trying to find 2 numbers that multiply to 3 and add to 4. Well, we have 1 and 3. Well, 4 is positive, so that makes 3 positive, and this other one has to be positive as well. All right, so I write it next to x, x plus 1, x plus 3. I divide by a. Now notice a is 1. If I divide by 1, it doesn't change the problem. So 1s don't do anything. I mean, if I move the 1 in front, it doesn't do anything either. So technically, you skip the last step, the division part, if a is 1. All right, so this replaces or changes to x plus 1 over x plus 3. On the bottom, that first thing is x minus 6. I'll leave that alone. And then that x squared minus 9, well, that is the difference of squares. I'm going to square both of them and put in 2 parentheses. Square root of x squared is x and x. Square root of 9 is 3 and 3. Plus and minus, different signs. That is fully factored. Right. Step 2 is find the restrictions. So restrictions come from the denominator cannot be 0. If the denominator is 0, we get undefined or error in the calculator. So you cannot have 0 on the bottom of a fraction. So what we're going to do is figure out what can x not be. So set each of these on the bottom, each factor, not equal to 0. Why just regular algebra? I just add 6 to both sides. So x cannot be positive 6. So that's the first one. This next one, x plus 3 can't equal 0. Otherwise, I have undefined. I subtract 3 both sides. X can't be negative 3. Now notice, remember I taught you about factors and roots? There's the opposite sign. It was x minus 6. The root became positive 6. It was x plus 3. It became negative 3. So this last one, I don't even have to do the work. I know it's going to be x can't be positive 3. So let's write our restrictions at the corner. There's 3 restrictions. X cannot be positive 6, negative 3, positive 3. All right. Last part and the fun part is just cross them out, and we're done. So whatever's the same on top and bottom, they cancel. So this is x plus 3, cross out the x plus 3. And that is it. So whatever remains, put them together. The nice thing about multiplication or division is we never ever have to multiply. You don't have to distribute. Just leave it as factored form. We want as many parentheses as possible. So that's my answer with those 3 restrictions. I simplified my fraction. Alright, sometimes you have to factor out a negative one to change some signs. So same steps here. First, factor each part. That first part right here has a GCF. I can take out a W. If I take out W, what's left would be 4W minus 3Y. This other thing stays the same. This bottom doesn't have a GCF. It stays the same. And that stays the same. Alright. So we've finished factoring. We find the restrictions next. So we set each thing on the bottom not equal to 0. Now these have multiple letters. So if it's multiple letters, it's going to have a kind of different restriction. It's going to be equal to a different letter. So I'm going to solve for y. I'm going to add 4y both 4w for both sides. So 3y cannot be equal to 4w. Sorry. Divide by 3. My first restriction is y cannot be equal to 4w over 3. Alright, the other one, so let's see, 5w plus y cannot be equal to 0. If I subtract 5y, or 5w, keep saying y, that's it. Y cannot be equal to negative 5w. Those are my two restrictions, so it can't be 4w over 3 or negative 5w. Last part is cancel out. Well, I see positive 4w minus 3y. On the bottom I have 3y minus 4w. Those are not exactly the same. They're close. The signs are different. Remember, you're allowed to rearrange the terms as long as you keep the sign. So my 4w on top is positive, 4w on bottom is negative. Well, to change signs, you just multiply negative 1. So if I take out a negative 1, I'll put on top. This turns to a negative 4w and a positive 3y. Well, positive 3y and negative 4w is the same on bottom, so this actually cancels. So the signs are different. They're similar. It will cancel as long as you use a negative 1, either on top or bottom. And that's all it cancels. So my final answer is negative 1w, so it's negative w times w plus y all over 5w plus y with those two conditions. Alright, when multiplying fractions, multiply the top by the top and the bottom by bottom, or straight across. Remember, we don't just multiply the top, and the bottom, we factor first. So let's rewrite that. 3 over, well, 4 is 2 times 2, times 7 over 6 is 2 times 3. Now, they do go together, so you can get rid of the middle part. So it's 3 times 7 on top, and 2 times 2 times 2 times 3 on bottom. There are no restrictions here because numbers aren't restrictions, only letters. But cancel out with the same, so this is 3's are gone. Whatever's left is your answer, so 7's on top, 2 times 2 times 2 is on bottom. Well, 2 times 2 is 4 times 2 is 8. This is my answer, no need to reduce. Again, if you factor and then cross out, your final answer is already in reduced form. So try this here. Well, I'm going to factor the top. I'm going to do the ACX method. So let's see. That will be, and I did it on the side, it will be minus 8 plus 2. Alright, this top right one is already linear. If it's quadratic, if it's an exponent, you got to factor it. There shouldn't be any exponents at the end. The bottom left, I'm going to do the ACX method again. Alright, so what multiply 64 and goes to 16? Well, 8 and 8, and they're both negative. And that bottom right one, I do the ACX method again. Let's see, what multiplies to 6 and adds 5? 2 and 3. Alright, so that's fully factored. Step 2 is restrictions. Set all the bottoms equal or not equal to 0. Figure out what x cannot be. Remember, if one of these is 0, the whole bottom turns to 0. So I'm going to change the sign. So the first one, x can't be positive 8. Because that was positive 8, 8 minus 8 is 0. Then 0 times anything is 0. The second one is a repeat. We don't care about repeats. This one, x cannot be negative 2. And this last one, x cannot be negative 3. There are 3 restrictions here. Alright, last part cancel out when we're done. X minus 8 cancel. I see x plus 2 and x plus 2. I see another x plus 8, x plus 8. Remember, everything cancels on one side. There's a 1 there left over. So 1 times that. So my final answer is 1 over x plus 3 with that restriction. Alright, when dividing, you just multiply the reciprocal, meaning flip the second fraction and just do multiplication. We never divide. So this problem changes to 4 over 7 times 3 over 4. Well, we just did multiplication, factor, 2 times 2 over 7 times 3 over 2 times 2. Put it all together. Cancel out, because there's no restrictions here. 2, 2, 2, 2. What's left is your answer, 3 over 7. Alright. This last one, same idea. I'm going to flip it first. So I flipped it to the second fraction. I made a multiplication. Then I'm going to factor each part. I did the difference squares for the top left, x method for the top right. I did GCF for the bottom left, and then x method for the bottom right. Next, I'm going to find my restrictions. There's one extra thing here. If you have division originally, you have to find the restrictions for the whole second fraction. So I have to do this part as well, instead of just the bottom. So the top one has an extra restriction. Y can't be positive 6, and the repeat of negative 3. Last, I cross out, and then I'm done. So I end up with that, where I have those 4 restrictions. Alright, here's your practice problem. If you do that, you should be fine in class. Again, this is Mr. Nguyen. Thanks for watching. See you later. Bye.